Hello and welcome everyone. I am Shirley Wong, Informatics Field Marketing Manager for Waters Corporation and also your moderator for today's webinar titled Continued Performance Verification of Analytical Procedures Using Control Charts in Empower Chromatography Data Software. Continued performance verification evaluates how the method operates during routine use in a QC laboratory and confirms that the generated data continues to meet performance goals. Routine monitoring may include trending of the system suitability data, tracking analytical results of real-time samples or standards, out of specification or out of trend investigations, or stability results. In today's webinar, we will discuss and demonstrate the use of Empower 3 control charts to facilitate the continued performance verification stage of the analytical procedure lifecycle approach. So before we begin, just a few friendly reminders. Please do use the question and answer feature to submit questions at any time during our webinar. We will get to as many questions as time allows during the live question and answer portion of our event. Also, you can use the cross arrow buttons at the top to maximize your screen for better visibility. After our webinar today, you will be receiving a follow-up email that will include links to download PDF copies of today's slides, as well as additional resources and bonus materials, such as an example Empower project for control charts, and of course, any questions that we were not able to get to today. Our presenters for today are Margaret Maziarz and Neil Lander. Let's get to know our speakers a bit. Margaret is responsible for analytical method development, validation, and method transfer within the Pharmaceutical Applications Development Team based in Milford, Massachusetts. Margaret specializes in the development of new applications on Waters Acuity UPLC, Alliant, Acuity ARC, Acuity QDA, Xevo TQS Micro, and related control software to support the sales and marketing organizations globally. Prior to joining Waters, Margaret worked at Boston Scientific and Purdue Pharma. Neil is the Principal Marketing Manager at Waters, focusing on informatics solutions. He provides internal support for Empower Chromatography Data Software and is focused on developing laboratory software solutions that help organizations achieve their scientific and operational objectives. He has held a variety of positions at Waters, including technical support specialist, technical trainer, and manager of customer education. Prior to joining Waters, he was an analytical chemist where he gained experience in both the cosmetics and specialty chemical industries. Before I turn this over to Margaret, we'd like to ask our audience to participate in a few short polls so we can get to know you a bit and also the work that you do. So our first poll for today, do you currently trend system suitability results? So you may answer yes, no, or not applicable. Again, the question is, do you currently trend your system suitability results? Yes, no, or not applicable. I'll give you a few seconds here to answer and then share the results. Do you currently trend your system suitability results? Yes, no, or not applicable. Okay, so let's take a look at our results here. So it looks like over 50% of you have answered no. About 30% answered yes, you do trend your system suitability results. And then a small bit of you have answered not applicable. Well, thank you very much for that response. And one last poll that we have here. The question is, what information related to method performance would you like to trend? Choose all that are applicable. System suitability, results, instrument parameters, column performance, or other. Again, the question is, what information related to method performance would you like to trend? Choose all that are applicable. system suitability, results, instrument parameters, column performance, or other. I'll give you a few seconds to choose your answers. Okay, let's go ahead and take a look at the results. Okay, so in terms of what information related to method performance that you'd like to trend, it looks like system suitability has over 85%. Next in line would be column performance. That's something that you would like to trend. Followed by that are instrument results, and then instrument parameters. And then, of course, there are some answers for others. So thank you very much for participating in those polls so that we can get to know you a little bit more and the type of work that you do, also the information that you would like to trend. So I will go ahead and turn this over to Margaret to get us started. Margaret,
thank you, Shirley.
Are you there?
I am
thank you,
here.
Margaret.
Yes. Thank you, Shirley. So let's go to the content of our webinar. First, we will give you a brief introduction to the method lifecycle management, or MLCM concept. Next, we will use Empower control charts to evaluate method performance characteristics in routine use. Then we will perform a live demo to show you how to create control charts in Empower software. The lifecycle management of analytical procedures is described in the FDA guidance on analytical procedures and methods validation for drugs and biologics. The FDA states that when a procedure is validated and implemented in QC, it should be followed during the life cycle of the product to assure that it always remains fit for its intended purpose. Trend analysis should be performed on a regular basis to evaluate performance and to assess whether the procedure needs to be improved or revalidated. The USP organization has proposed a new general chapter that is the analytical procedure lifecycle, which introduces a holistic approach to management of analytical procedures throughout their entire lifecycle. This approach integrates all current guidelines on procedure validation, verification, and transfer into one lifecycle process. It implements the lifecycle management concepts for development and manufacturing of pharmaceutical products that is described in the ICH guidelines Q8, Q9, and Q10. The intent is to use the scientific knowledge and quality risk assessment-based approach to determine if the analytical procedure needs improvement. The life cycle approach is based on a three-stages concept, but the fundamental component of this approach is having a predefined performance requirements for the analytical procedure. These requirements are referred as the analytical target profile, or ATP, and are driven by the purpose of the method. If we look at the three stages, the first stage includes method design and development. In the second stage, performance qualification or validation is conducted to show that the procedure is suitable for its intended use. Stage 3, or continued method performance verification, includes routine monitoring and trend analysis. In other words, the continued method performance verification evaluates how the method operates in routine use over a long period of time and confirms that the data generated by the method always meets the performance requirements defined in the ATP. The continued performance verification may include routine monitoring, trend analysis of the system suitability results, reportable results of real samples, and column performance characteristics, as well as tracking out-of-trend data. Control charts from the Empower 3 software enable quick trend analysis of the performance characteristics against the predefined requirements. Next, we will use Empower control charts to perform trend analysis of the system suitability results, assay results, and column performance over routine use. As you may know, system suitability is a regulatory requirement to verify that the chromatographic system is performing as intended at the time of use. According to the USP General Chapter 621, the system suitability tests are used to verify that the resolution and reproducibility of the chromatographic system are adequate for the analysis to be done. The other system suitability parameters that we offer monitor may include repeatability of retention times and peak areas or peak symmetry. For each run, we must verify that this test meets the acceptance criteria. The system suitability option in the Empower 3 processing method calculates system suitability parameters according to the guidelines defined by the United States, European, and Japanese Pharmacopoeia. Just simply enable this function by clicking on the box and select guidelines required for your analysis and process the data. Empower will calculate the suitability results and compare them against the acceptance criteria. However, the user must define the criteria in the Limits tab located in the processing method. We must enable flag values outside the limits so that the Empower software can quickly identify results that exceed the limits. Then simply enter the parameters and their limits into the suitability limits table of the processing method. In this example, we are showing parameters and their limits for impurity F-peak. These parameters include % RSD of peak areas, % RSD of retention times, USP resolution between peaks, and USP peak tailing. The interactive system suitability mode in the Empower software can be used to perform real-time processing, which quickly identifies injections that fail the suitability criteria. This will automatically stop the sample set run, which saves consumption of your samples and solvent by the system. To use this feature during the run, we need to select Run and Process mode, which constructs Empower to generate results as it acquires each injection. Then choose Step Unfold. With this mode, Empower compares the results against the predefined criteria during the acquisition and stops the run immediately when the results fail the specifications. Here's an example of a sample run with interactive system suitability mode. The replicate suitability injections are displayed on line 3 of the sample set method. These injections are flagged because they fail the specified limits. Hence, Empower stopped the run. The user can then review the system stability results to check which injection or parameter failed the criteria. In this case, peak 3 exceeded the defined limit for % RSD of peak areas. Here we are showing another example of the system suitability determination for a different method. That is a method for related substances analysis. Shown here are a summary of 5 replicate injections. In this case, all results met the criteria for repeatability of retention times, peak areas, resolution between peaks, and peak tailing. If we want to implement this procedure in a QC lab, we would need to monitor these parameters over routine use to assure that the system suitability results continuously meet the predefined performance goals. We can perform System stability trend analysis over time using Empower control charts. As for example, here we are showing trend analysis of the percent RSD of peak areas for impurity A based on the 5 replicate injections over 20 separate chromatographic runs. For each run, or the number shown on the x-axis, Empower displays percent RSD on the y-axis. The performance target, lower and upper limits, as well as the warning limits lines are displayed in the plot. The trend plot shows that the percent RSD remains below the upper limit. However, for 2 chromatographic runs, that is 13 and 14, percent RSD reached the upper warning limit. Approaching a warning limit may be an indication that some preventive and corrective action might be needed to prevent failures or getting out of specification results. Here we use control charts to examine resolution and peak telling of impurity A over long-term use, which met the specifications. Overall, monitoring performance characteristics over routine use will provide confidence that the method remains in control. Let's now look at the trend analysis of the reportable values. As stated in the U.S. Chapter 1220, the reportable values generated by the method are used to confirm whether the manufactured product meets the specified standards for identity, quality, safety, and potency. Performing trend analysis of the reportable results over the lifetime of the drug product will enable a quick identification of out-of-trend results or deviations from the product specifications or acceptance criteria. To demonstrate trend analysis of the reportable results, we will use assay results for related substances analysis. And here's an example of a sample with 3 related substances or impurities. You can see that each impurity is at 0.05% level. If we were going to use this method over a long period of time in a QC lab, whether to support release testing of manufacturing batches or doing stability study, we would want to examine this impurity content to confirm it always is below the specification. In this case, we can use Empower control charts to perform trend analysis. But first, we must specify limits for the impurity in the Limits tab of the processing method. We want this impurity to be below 0.1%, and we set the warning limit as well, which in this case is set to 0.075%. And here's a trend analysis plot for impurity F, generated using Empower software, which shows that the content is below the upper limit across the separate chromatographic runs. In this example, we are evaluating API assay results generated over time. The acceptance criteria for percent recovery of our API is set to 97 to 103%, with a precision of replicate results less than 1%. So we use Empower control charts to generate a trend analysis, and the trend plot shows that both the percent recovery and the percent RSD are below the requirements. So you can see that using control charts for trend analysis of the reportable results helps to identify out-of-trend results that may go undetected when using summary reports. Whether evaluating results during ongoing stability study or release testing of the drug product, control charts in the Empower software enables quick trend analysis of the data generated by the method. So when your assay column is used for a specific assay, tracking the injection number or and column pressure will help to decide whether the column is approaching the end of its life so that the new column can be installed. Monitoring play counts may also help to predict when the columns start to deteriorate. Therefore, tracking column performance characteristics over a long period of time may enable users to predict when corrective measures are required to prevent failures of the sample runs. Empower control charts enable users to track column performance characteristics over routine use against the expected requirements. But first, we need to enter performance requirements or limits for our column in the processing method of the Empower software. In this case, these parameters include system pressure and a column USP play count, as shown in this example. The operator warning limits for our parameters are defined in the system limits table as shown here. Here we are tracking system pressure and a USP play count for a related substances method. Over 200 injections of standards and sample solutions were made onto the column. You can see that the pressure and the play count met the performance expectations for all injections. Here is a different example where we are showing system pressure trending for assay method for telmisartan tablets. We made 3,000 injections onto the same column with the same lot. Trend analysis shows that the pressure remains stable, maybe for some slight increase at approximately 2,100 injections. In this case, pressure increase indicated a need to wash the column, which regenerated the column and reduced the pressure. So you can see that tracking column performance may enable users to establish how many injections they can make onto the column for a specific analysis, or to identify any deviations from the performance trends so that the corrective action may be taken before problems happen. Now my colleague Neil Lander will perform a live demo on how to create control charts in Empower software.
Thank you, Margaret, and thank you to everyone attending, taking time out of your busy day to join us today. We really appreciate it. So I'm going to do a two-part demonstration. The first part will be on how to create control charts, and then the second part will be how to actually use the control charts. And we'll probably state this more than once, but for those of you that have Empower software that are watching and listening today, you need to have the system suitability option to do this, and that gives you the ability to create the control charts, and they are essentially report groups, as you'll see when I go through this demonstration. When I begin the demonstration, for those of you watching, if it doesn't automatically start, then you may have to click the Start button so that you can hear and see what I'm doing.
Okay, now I've switched over to my Empower screen, and I am logged in with a unique username and password. This account gives me the necessary privileges to create the report method. And that's what a control chart is. It's a report method, very specifically a summary report, because we're summarizing multiple results. But before that, let's first open our project. And a project, which looks like a little yellow file folder, this is a place where we do our work. We have all of our methods that we've created, data that we've collected, and results that we have generated. So let's take a specific set of results that we can use to create the control chart. And before we do that, let's look at the chromatography. We'll right-click and go to Review. We can look at the chromatography. We can see that we have 9 peaks that are reasonably separated. And we can also see in this set of results we have calculated areas and heights. And we also have some averages calculated for USP plate count, USP resolution, and so forth. let's take a look at the processing method. And very specifically, we're going to go to the Limits tab. And this is part of the System Suitability option. We can set limits and target values for peak fields for the various peaks that we have in our chromatogram. And we can do this on a peak-by-peak basis. So once we highlight a peak, we can then come down to the Suitability Limits table. And if I click in the next available row, from the drop-down list, I have a list of different peak fields that I can select from. And this would include standard peak fields that come with Empower, custom fields that you may have created, and of course our system suitability fields such as plate count, tailing, resolution, and so forth. Let me just eliminate that line. And again, this can be done on a peak-by-peak basis. So for any peak field that I select, I can set a target value, I can set lower and upper error limits, and if the result for that field exceeds those limits, then this would be a faulted result and Empower would flag that. If we use the limits, error, as well as warning, these will be a visual on the control chart, as you will see. That being said, let's close review. I'm not going to save any changes to the method, and let's go create a control chart. Right-click, Preview Publisher, and you'll see it's a very simple task. So we're going to make a new report method. And Empower does default to an individual report method when you make a new one. So I'll go into the method properties and we'll make a summary by all. Let's also put this on the main page view and let's build our control chart. Over on the left-hand side, we see all the different report groups that we can add to a new report. We're going to head down to the last selection here, which is the System Suitability Groups. Expand. There are 4 different types of System Suitability Groups. And the one we're going to work with is the very last one, the System Suitability Summary Plots. I'll expand that a little bit further. And these are the 3 report groups that come with Empower. And the one we'll take advantage of is the Summary Scatter Plot. This one summarizes area. So it's area versus run number. And what we'd like to do is we'd like to make a control chart that summarizes the percent RSD versus the run number. So we can look at the percent RSD for the area over time. And so let's make that change very simply. Right-click, Summary Plot Properties. Here on the Sum Plot tab, you can see area has been selected. We're going to go for the RSD of the peak areas. And let's do one other thing while we're here. Let's go to the Order By tab. Let's put some sorting in. So I'm going to go for the injection list and add date acquired in ascending order. Very simple. Click OK. Go to Print Preview. And we have a control chart. It's that simple, where we now have the RSD for the peak areas versus our run number. Now we can make these control charts a little more appealing visually so that things will stand out, such as are the samples passing or failing, and are we near a warning limit? Have we exceeded an error limit? Let's go do that, and that's fairly simple to do as well. So we'll close Preview. We'll go back into the Plot Properties. And on the Bars/Points tab, for normal data, data that's within our limits, we would like to have solid dots, and we're going to change the color. And if it's passing, let's make it a bright green. And for the faulted data, it defaults to red, so that's good. And then we can go to the Colors tab, and we can also change the line style and the colors for our warning lines and error lines. So the control warning lines are dash dot. Let's make those a solid line. Now we can change that color. I'm going to take purple in this case for the warning. And for the control error line, which is already solid, let's make that line red. Click OK. let's complete our report by adding in a header and a footer. Those are composite groups. So I'll click the plus symbol next to composite groups. There's a general header group that comes with Empower. I'll double click that and add that into the header field. And then there is a general footer simple, which is another default group. Double click that, put that into the footer. And that's a good one to have because if the report is multiple pages, this will automatically paginate for us, which is a good thing. All right, let's now save our report method with a name, and we'll call this RSD Peak Area Control Chart. Save and preview. So now we have a complete report. It's got a simple header. We can see for the control chart, and you're going to have one control chart per peak in this case. We have the RSD for the peak area versus the run number. These results are well within the error limit, so the dots are filled in with green. We see the upper control limit, the warning limit, in purple, and the upper control limit for error in red. And if I zoom out, you can see down at the bottom that it has paginated. In this case, we've got 5 pages. So creating the control chart is that simple. Now that we have our control chart, let's log out of Empower and log in with a different username and password and a different set of privileges. And what I'm going to do is log in as a routine user. And now I'm going to use this control chart to plot out a much bigger data set. So I'm going to log in now with a different account, and I'm going to open the same project. And then I'm going to go to the result sets and select a whole series of result sets. So we have a bigger sampling. Right click, preview publisher. And this time around, we are going to use the following report method. And from the drop-down list, I'm going to select the report method that we just made, the RSD peak area control chart. Click OK. Let's make that full screen. And now it's the same control chart. However, this time around, we have a much bigger sampling. And we can see we are plotting the RSD for the peak areas against the run number, and we have a bigger sampling in this case for each of our peaks. It's that.
So we have here a list of tools that can be used to monitor performance characteristics of your method over routine use. We've already described the use of Empower control charts for trend analysis. We also have reference standards that can be used for benchmarking and performance checking of your system during routine use across multiple instruments, analysts, or sites. We have the eCord technology, which we introduced with the Acuity, and that's available with all the UPLC columns. It provides a unique identifier that is permanently attached to the column hardware, and this enables monitoring and tracking of column usage, performance, and lifetime. When utilized in conjunction with Empower 3, the column information is linked to the raw data, enabling full data traceability. We also have our New Genesis software, which seamlessly links data from the lab to the business operations, including sample submission, results review, stability testing, multi-vendor software connection, laboratory inventories, and data retention. And finally, performance maintenance. Routine performance maintenance helps to keep your system running properly, minimizing overall instrument failures. So in summary, the continued performance verification of the lifecycle approach routinely examines performance of the method routine use. Therefore, large amounts of data must be reviewed to confirm that the method always meets the goals. Control charts and Empower 3 software provide an easy way to perform trend analysis of data generated by a method which allows quick identification of any out-of-trend results or deviations from the performance goals. Whether examining system suitability, trending, column performance characteristics, or reportable results for a specific product, Empower control charts will help to assure that a method continuously generates fit-for-purpose results. That being said, we will now move to the question and answer period. And I know that a number of you have indeed submitted questions, so my colleague is going to start sending me those questions. It's right in front of me, sorry. Do all results have to be in one result set to create a control chart? No. You can have data, or I should say you can have results from multiple result sets to create a control chart. So if you go into the project window, you could go to the Result Sets tab. You could grab, as you saw what I did during the demo, I grabbed multiple result sets, and I was able to use my control chart. Or if you prefer to take individual results from different result sets, you could go to the Results tab in the project window, grab them from there, right-click, and go to the report publisher to use the control chart or build a control chart. So no, the results don't have to be in one result set. Next question, please. Can I use custom fields to track method performance characteristics over time? Yes, any custom fields created in the project that you're working in can be used to generate control charts for trend evaluation of method performance. So you had a quick look when I was making the control chart and I was deciding what to choose, say, for my y-axis. The default was area, and I chose %RSD of area. So anything that's in that list, I can use, whether it's a standard field or a custom field, perfectly allowable in terms of creating a control chart to track that parameter. Thank you for that question. Next question, please. If a value exceeds a warning limit, does Empower flag that as a faulted result? No. So there are two sets of limits, as you saw, and the warning limits do not flag anything. It's the lower and upper control errors that if the value exceeds that value, that's when it gets flagged and that's when it gets saved as a faulted result. So the warning, the way we use the warning is visually in the control chart. You have the warning limit so that, as Margaret showed in one of her examples, you know, you're getting close to being above a limit or below a limit that we want it to be at. So that's just a visual on the control chart. So that's a very good question. Thank you. Next question, please. How would, I'm assuming, one set upper limit and lower limit for impurities? Well, that's really going to depend on your method. I would think that when setting any limits, you probably need to look at some historical data over time to see where the limits fall, but we'd have to go back to the basics and look at what are the thresholds for reporting impurities. And setting those guidelines, you have the ability to do that in the impurity section of the processing method. That being said, you could then set your appropriate limits in the Limits tab of the processing method. So it really depends. Are we talking about the reporting threshold? Are we talking about the identification threshold? Are we talking about the qualification threshold for impurities? There are different thresholds according to the ICH. So you need to know that beforehand, and then it's very easy to go in and set those limits, which actually was in one of Margaret's examples as well, where she was looking at a % impurity. That's a great question. Thank you very much. What's our next question, please? Can we trend data for other applications such as SEC, which is size exclusion chromatography, or data acquired on different instruments such as GC? Absolutely. It's not application dependent. So whether you're doing LC or capillary electrophoresis or SEC, you can certainly do control charts and track your data and look for trends in your data. And as far as GC goes, this question does come up frequently. As long as you can get the data into Empower, whether it's some type of instrument that Empower controls or it's a legacy instrument and we're bringing the data in through an A to D converter box, we call it a Satin box. As long as you can get the data into Empower, you can certainly track the data and look for trends in the data over time. That's a very good question. Thank you. Next question, please. Is it possible to perform stability trends for a specific product during a long-term stability study? Absolutely. My first question would be, what parameter would you be looking at in that stability trend over time? Is it going to be the amount of API in the sample over time? Is it going to be the amount of impurity in the sample over time? Maybe it's both. So the answer is yes, and we might create two control charts and have one track the API over time and one track the percent of the impurity over time. So absolutely yes. Good question. Thank you very much. Next question, please. Can the trend charts include data from different projects? Yes, this can be done using our NuGenesis software. And that software works very nicely together with Empower. So if you print the reports from Empower into NuGenesis, once the data is into NuGenesis, you can select the results from the multiple projects to pull together and create a report in NuGenesis to look at the trends in that data. So this is something that with NuGenesis in conjunction with Empower absolutely can be done. So good question. Thank you. Next question, please. Is the column limits different from using E-cord tracking? Not quite sure what this question means. Maybe you can elaborate. So the E-cord tracking, for the E-cord, Empower reads information from the column, and it is permanently stored in Empower. So the basic stuff is, you'd have your column name and serial number, for example, part number and things of this nature. But it also will track maximum pressure and maximum temperature and things of this nature. So there's about somewhere between 6 and 13 fields of information that Empower stores from the E-cord permanently in Empower. So we have those fields, but then there are other fields that we can track regardless of whether it's an E-cord or a traditional column. Things like Margaret showed, the plate count over time. Maybe it's the resolution between a critical pair of peaks over time, tailing factor over time, and things of this nature. So we need to define what you mean by column limits, but for any column, whether it's E-cord or not, you can track all the aforementioned things. The E-cord just gives you some additional information that's automatically collected from that chip. So it's a good question and an intriguing one. Thank you. Next question, please. Can limits be set for fields within the dissolution module as long as the field of interest is in that drop-down list? And Margaret showed it in her slides, and I showed you during the demonstration. You highlight the peak in the upper table when you're on the Limits tab. You come down to the middle table, and you click, and you see the whole list of fields there. As long as the fields are in that list, then that's something you can set a target for and you can set limits for. So again, I don't think it's application specific. It's whether or not the fields will be there in the list, and most of the fields will definitely be in the list. So another very good question. Thank you. What is the next question, please? Second, the limits work using result processing each injection instead result set. I'm not sure I understand the question. That's a tough one. I'm not really sure I understand it. I apologize. I'm thinking you're looking, is it results? So, the answer is yes. To do these control charts, you need results. Because if you think about it, if I have a raw chromatogram where I haven't integrated the peaks or I haven't calculated plate count or tailing factor, I don't have any values available to me to track. So I'm not sure if that's really what you're asking. If you can clarify, we will attempt to give you a good answer, but you have to have results to generate these control charts. Okay, what is next, please? For the monitoring of system pressure per run number, when is the pressure taken? At the beginning, at the end, or all along the injection? That's a great question. You as a user can decide at what point you want to track the pressure. You could do it at the beginning, somewhere halfway through, somewhere at the end, or you could do all three. So what we do is we use a custom field to set the time at which it's going to record the pressure. So if you wanted to do a particular point in time during the chromatographic run, that's very easy to set up. It's a very simple custom field, and then it will track the pressure at that time over your chromatographic runs. So it's up to you where you want to track it from. Thank you. Next question, please. If data is located across multiple project folders, for example, if a subfolder is created each month to hold that month's data, is it possible to create a control chart to trend across multiple folders? This is actually very similar to the question that we had earlier, where the individual asked if a control chart can be made from data across multiple projects. This would be possible using our New Genesis software in conjunction with Empower, yes. Thank you. Next question, please. If system suitability was run with samples injection together, are the control charts for system suitability of different result sets achievable? I'm trying to understand this question. I apologize. If system suitability was run with sample injection together, are the control charts for system suitability of different result sets achievable? Okay, I'm not completely sure I understand the question, but we could certainly make control charts of system suitability over multiple result sets, or we could do a control chart per result set. I'm not quite sure that's what you're asking. I would like to get some clarification on this. So forgive me, but I'm not 100% sure what you're after. If you can, send us another question or a clarification and we'll help you out. Next question, please. If the system suitability parameters limits are set in a specific processing method, how Empower links it to a sample set that is running if I choose the stop on fault in the sample set? I don't recall referencing the processing method when starting an analytical run. Okay, so in order for this to work, as Margaret showed in one of her slides early on, so you have to be, I would recommend the run and process mode, and then you have the ability to set it to stop on fault. So what you have to do is, in the method set, where you put in your instrument method, you have to put in your processing method. And then that method set is in your sample set method, and so it makes the first injection in the run and process mode. It goes to process that injection. If it fails the limit, it would trigger the stop on fault. So you have to make sure that your processing method is in the method set. And even if it's 3D data like PDA or MS data, so you use the channel table, you derive your channel, and you put your processing method in the channel table. As long as the method set has that processing method, then it will work very nicely. Good question. Thank you very much. We'll have some time. What's our next question, please? Can exact dates and other information be added to the report method rather than a generic run number? Knowing analyst, instrument, column, etc. helps identify other trends within the results. Well, you can certainly, you do have choices for the x-axis, but what I would also do is I would have a table that goes with that control chart to document all of the relevant information for each of the data points that you're looking at across that control chart. That would be my recommendation. You can also put labels on the dots in the control chart. You don't want to put too much information in the control chart because then you can't see the trend. So that's why I say I would recommend a table underneath that would track some of that other information for you. So good question. Thank you. Next question, please. Do you have to install additional software to have this feature in Empower 3 FR2 SR2? No. What you need is the system suitability option. The quick history lesson is we started with Millennium software in 1992, and early on we had the system suitability option with control charts. So as long as you have the system suitability option, the ability to create control charts is not version specific. So thank you for asking. I appreciate it. Next question, please. Is it possible to distinguish trend variations caused by analytical related variations from sample production process variations? It's a good question. I want to make sure I understand what you're after here. Distinguish trend variations caused by analytical. Well, I guess it depends. I mean, the control chart is just going to reflect an overall trend in your results, but with each result you have connected to it how the data was collected and how the data was processed. So if I had, I don't know, different instrument methods or different processing methods or whatever I was doing to generate those results, that information is linked to each individual result. Now in terms of sample production process variations, maybe through some custom fields, could say, you know, these batches were manufactured on this date with these conditions, so that as we look across, if we see something doesn't look right, we can relate back to that. This is an intriguing question. I'd need more information to give you a further answer, so perhaps we can have a follow-up on that. That's a great question. Thank you very much. We still have time for one or two more questions. Do you have to collect another channel of data for pressure tracking? So in your instrument method, you can turn on the pressure channel, and what that'll give you is with each injection, you'll have, in addition to, say, your chromatogram from your UV detector or whatever detector you're using, you would also have a pressure trace so that you could look at the pressure trace over the chromatographic run. But if you want to track pressure, as Margaret showed in her slides, then what you'll have to do is, yes, you will turn it on, but as mentioned earlier, you can determine at what point in time during the run do you actually want the pressure recorded, the numerical recording of it, so that you can make that control chart for pressure. So yeah, you have to have that channel for tracking pressure at a specific time. That has to be turned on in the instrument method. Good question. Thank you. Next question. Can we perform trends using only signed off results? I'm not sure I understand your question. You can do trends on any results. It doesn't have to be signed off. Maybe you can elaborate on this one, but I can make a control chart on any set of results that I've generated, and typically, although not always, it would be, let's review the results, and then we sign off. So somebody might look at the trend over so many result sets and then sign off, and you can make a custom reason why you're signing off based on that control chart. I hope that answers your question. There might be more to that depending on what you're looking for. Thank you. We have time for one more question before we wrap it up. Is there a way to remove limits being flagged for samples? Well, there are a couple of options in Empower. I'd have to go back and look. There's a couple of things that can be turned on and off in the processing method. But I'm not sure if we can do it for specific types of samples. We have the option in the sample set method to say no system suitability for certain lines. But in the processing method itself, I'd have to check on that. That one I'm not sure there's a selection for. So I owe an answer on this one. I'm making a note of that. Thank you. All right, we only have a couple of minutes left, so we are going to turn it over to Shirley as she has some closing remarks. Shirley?
Thank you very much, Neil, and also thank you, Margaret, and all of our audience members for attending our live webinar today. Just a reminder that you will be receiving a follow-up email from myself where you will have copies of the presentations. I know some of you have already asked that question, so you'll receive PDF copies of the presentation as well as additional resources and bonus materials, including an example Empower project with some of the information that you've seen here around control charts. And also, I know that we weren't able to answer all the questions as we are out of time, but we will certainly reach out to you and continue the discussion and answer your questions via email or over the phone. So thank you very much, everyone, and have a great rest of your day. Goodbye.